Hi guys, welcome to my channel. So in this video we'll get mensurated. All right, so we're going to look at advanced mensuration, and in this video to be particular we'll look at a lot of things that we're going to look at in this video. There's arc length, the area of a sector, area of a segment, and angle. So allow me just in this video to just explain what is involved in all of that. I'll just explain arc length, how to find the area of a sector, area of a segment, and also the angle theta when we are given. And I'll create a separate video. We're going to solve the area of a sector as well as how to find the angle theta, because those are the ones that I found common when I was going through some past papers. Now, for us to flow smoothly in this video, there are some of the important formulas that you have to keep, and these are the circumference of a circle. So you need to make sure that you keep this formula here, because this advanced mensuration will play around the circle there. So we have to look at the circumference of a circle. Remember, it is 2 pi r, and also the area of a circle is also pi r squared. So please keep those in mind. Let's get started. What is the arc? What is the sector? What is the segment? And what is the angle theta in this advanced mensuration? So I'll start with, first of all, I have this circle of mine here, and you notice that from this circle, of course, when we see a circle, we know that if there are angles, all these angles add up to 360, isn't it? Yeah. So when we talk of the arc, maybe the question exam says find the arc length. Look at those radius that joins at the center. When they join at the center, they're going to form an angle theta, isn't it? Now, where they go to the circumference of the circle, we find that there is this arc here which looks like a curve. This is the arc which they are talking about. And if the question says find the arc length or the length of an arc, they mean find the length of this from here up to here. Gone are the days, I remember in geography, where we would go in an exam with a string, then we try to bend it nicely, and then after bending it we take it on a rule. But this one, no, this is mathematics. We have to find some means on how we can find the length of this arc, of this curve here. Now, how do we find the value of such? Remember, I said keep those two formula. One that was for the circumference of the circle, and the other one was for the area of a circle. So since we're dealing with the circle alone here, we just have to consider on the circumference of a circle. Now you notice that from the end of this part here, we have a radius that goes to the center, and also here we have another radius that goes to the center. So there are two radius here, or I don't know if it's radii, or yeah, there are two of them, and then they form an angle there. Now looking at this part has been taken as an angle from a hole. Which hole are we talking about? The hole as in HWO, the whole of the angle, and we say the whole of the angle is 360. So we don't know what the size of this angle is, but we know that it is out of 360. Now 360 of what? Of the whole again of the dimension which is called the circumference of the circle. So from this explanation so far, we can see that the arc length is equal to this theta there over the whole. The whole of what? The whole of the angles. And the whole of angles is 360. Then theta over 360 of what? Of the whole, again, the whole of these dimensions, the whole of the circumference of the circle. And the whole of the circumference of the circle is 2 pi r. That's it. So that's how we find the arc length, or the length of an arc of a circle. So remember this formula. The arc length is given by pi over or theta over 360 times 2 pi r, of which we can go further by saying all of this. We say arc length is equal to, we can just take theta that other side, isn't it? So it becomes 2 pi r theta over 360. Again, we can simplify it further by dividing, isn't it? Yeah, we can divide 2. We can find the common denominator, the highest common denominator of 2 and 360 there, which is 2. So finally, we can say arc length is equal to just pi r theta over 180. That's because 2 into 2 is 1, and then 2 into 360 is 180. Then we find the arc length. So this is the formula. Whenever they ask you a question to say find the arc, the length of this arc, of course you'll be given the radius, you'll be given there, and of course you'll be given the angle theta there. So just apply this formula. Arc length is equal to pi r theta then over 180. Then you're good to go. Let's look at another one. The sector. What is the sector? Again, remember, we're coming from this part here. Now we're looking at this dimension from here up to here. Now, when we talk of the sector, we look at the whole part of this, like it is shown here. The whole of this is called a sector. Now, under a sector, you'll be asked again to find not the length of the sector, that maybe in more advanced mensuration you can find the length of the sector, but can there be such a thing? I don't think so. But we're going to come across questions like find the area of a sector. Now, how do you find the area of a sector? Okay, again, on the area of a sector here, you notice again that we are looking at this part, and this part has been taken from what? That is from the whole angle, isn't it? We have the theta there, the angle theta there. The angle theta there is taken from a whole of 360, isn't it? Now, 360 of what? Because here now, we are no longer dealing with the line, but we're dealing with the circle itself. So now we're looking at the individual angle times the individual part that has been taken from a circle. So how do you think the formula is going to look like? Remember, we're looking at the individual angle over a whole times the individual sector of this part over the circle there. So let us look at how our formula is going to be like. So we are forming on this one, we are forming formulas depending on what I'm explaining, not because it is there in the book, but we have to make sense of the formula. So this sector here, we have an angle theta there, isn't it? So this angle theta is taken out of the whole of this thing, which is 360. So we only have this part there. And again, if you look at this part that we have here, it's out of a circle. So again, we have to look at the area of a circle, isn't it? So it is this one of the area of a circle. So meaning that the area of a sector, area of a sector is given by this theta, which has been put for us there, over the whole of the angles. It's 360 times this part again has been taken from the whole area of a circle, isn't it? And remember those two formulas that I've given, one we've used it here, which was 2 pi r, that was the length, the circumference of a circle, isn't it? Now this one, we want to consider the area of a circle, which is pi r squared. That's it. That is the formula for the area of a sector. So just pay particular attention in how exam questions are asked. Have they given you these radius or radii as mentioned earlier on? And do you have an angle theta there? If you don't have an angle theta, they'll at least give you the area segment, the area of a sector, so that you can find the angle theta. All right, we move on. Let us look at the segment. The segment, it's where those two radii meet the circumference of the circle. We're going to make a straight line so that they can we can form a triangle, a sharp triangle. Now on this one, there's no sector there. Now after making a triangle, we have a segment. I'm using the word again to describe it. We have the upper part that will be straight down and then curved upwards when you look at on top there. So this is the part that I'm talking about, which is the angle, which is the segment. Now sometimes we may be asked to find the area of this segment. So what do we do? All right, so on this one, guys, you have to understand again that we first of all, we know how to find the area of a sector, meaning that the area of the whole of this part here, we know how to find it, isn't it? And we have to apply those trigonometric ratios where we have, let's say here this is r and also this is r, and we have sine there. Remember how to find the area of a triangle using the sine rule, where we say the area of a triangle is equal to AB squared times sine C. Now here we have r and here we have r. So the area of this part here, it is half r times r sine theta. The area is equals to r times r half times r times sine theta. In simple, since we're dealing with r, so you just say r squared, isn't it? So half r squared sine theta, that is the area of this triangle here. But we're not looking for this area, we're looking for this part here. Now, why have we put in the aspect of looking at the area of this? Well, that is because after finding the area of this segment here, we're going to keep the answer. Then we find the area of this triangle. After finding the answer, we subtract it from the area of the whole of this sector there. So our formula will look like this. First of all, we need to have the formula for the area of the whole of this part here. And we said this part from here, then curves there, and then comes here at the center again there. It forms a segment, a sector, isn't it? So the area of a sector, we said area only that it is theta over 360 times pi r squared. Then after finding this, we say minus the area of this triangle here. And the area of this triangle from the sine rule, we say it is half times r times sine theta, isn't it? Which is r, so times r squared sine theta. I don't know if you're able to follow what I'm saying or what I've just explained. I think it will make more sense when we are going to solve some examples. So to check out the example that we're going to solve in advanced mensuration, please, I advise you to click the link in the description of this video, and then we'll meet on the other side of the video. So don't forget to subscribe, and please, I love those comments that you're commenting. Keep on encouraging, even recommending these videos to your friends so that them too can pass. Otherwise, it has been wonderful for me. Don't forget to like the video, share, subscribe, and then turn on the bell notification. Yeah, just that bell.